Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Hey y'all, happy Sunday. Hope everybody is doing well. Welcome to the big show. If this is your first time here, please note that I have subscribers only turned on. meaning only subscribers can take part in the chat. And you must have been a subscriber for at least one day. Unfortunately, that was done to keep the bots and the trolls out of here, those who would choose to try to take over the chat in a live stream and totally derail it. Sorry it has to be that way, but what can I say? So if this is your first time here, go ahead and subscribe to the channel now. Then you can participate in the chat next week. Again, I'm sorry it has to be like that, but that's the world we live in these days. So what can I say? My apologies. Today we're going to talk about something that was mentioned last week, and that is editing the number of passes in the Vectric software, specifically in the Profile Toolpath and the Pocket Toolpath. Those are the only two toolpaths that will allow you to do this. And they are important, and I'll show you why in a few minutes. They're pretty customizable too. But before we get into any of that, as usual, I want to say hello and thank you to my friend Steve at Harneo Media. Now, again, I say it every week. I've been singing Steve's praises for ever since he started Harneo Media, as a matter of fact. And I do it that way for a reason. Well, I do it for several reasons. Number one, he's a friend of mine, and it's a small business, and I support small businesses. Number two, he's very, very good at what he does. And I still don't know your secret, Steve. I don't know if you sleep or not, or if you even get out of your chair. He's just that good. He's on top of it before you know that there's an it for him to be on top of. He's extremely competitively priced. I mean, he charges less than a lot of similar services out there. And after a couple of months, you wonder how he gets away with it so cheaply. But, I mean, nothing less than phenomenal results is what you're going to get with Harneo Media. And the reason it's going to be phenomenal results is simply because it's 100% personalized service. When you're dealing with Harneo Media, you are dealing with Steve. That's it. No ifs, ands, or buts. It's not some nameless, faceless person in a call center somewhere who may or may not ever speak with you again. You're always going to be dealing with Steve, and that speaks volumes right there. So if you or someone you know are even toying with the idea of establishing a website, maybe you want to present your products or services to the public at large and are tired of paying commissions to do so, reach out to Steve. Do yourself a favor. Go to harneomedia.com. There's a link in the description of every video and every live stream on this channel. Real easy to find. Go to harneomedia.com, click that contact us link, shoot Steve a message. Tell him what you want. And he'll talk with you. He'll work with you. He's a great guy, and pretty soon you'll be singing his praises too. So that's Harneo Media, sponsor of MarkLindsayCNC.com. I want to say thank you, Steve, and I hope you and yours are doing well, and wish you a Merry Christmas. Okay, getting into what happens. Uh-oh. Steve does accept bonuses in the form of chocolate. Steve is probably the only person I know of who has a candy selection or a snack selection that is even bigger than mine. I mean, Steve doesn't have snacks. He has groceries, all right? Let's just say it that way. His sweet tooth cannot be satisfied. Anyway, So, anyhow, sorry about that. Didn't mean to throw you under the bus there, Steve. So, yeah, we're going to get into edit passes, and I think probably the quickest way to do that is to just go click, and there we are. As usual, if you have any questions, comments, concerns, throw them in the chat, and we will get to you just as lickety-split as we can. So, let's see here. What we've got, I've got just a vector out here because I need something. What am I doing here? Why is that still? Yeah, talk to Steve. There you go. I don't know why that banner just decided to pop up, but there you go. All right, let's get here. I have a vector out here because I need something. So there's my vector. And we're going to look at the profile toolpath. And what we're talking about is right here, down in this area right here. Now, what I've got selected right now is a 1/2 inch end mill with a cut depth of 0.875. And this is telling me that it's going to need 4 passes to cut that 0.875. Well, now where does it get that 4 passes? Well, I'll show you. If we go over here into the tool database, we're going to look at the tool data on this particular bit. And I have a pass depth of 1/4 inch selected. They're set. I'm going to go on a little side excursion here, so stick with me for just 1 minute, okay? Because I need to explain myself. I take a little bit of ribbing every once in a while about my pass depth, my feed rate, plunge rate, and spindle speeds. Not often, but often enough. There are a couple of reasons for that. I set conservative pass depths, feed rates, and plunge rates because I do videos. And there are a lot of people who have professional quality machines like my Avid. I know some of you out there have Legacy Mavericks. Some of you have Laguna IQs and things of that nature. But a lot of you have hobby machines. I'm talking X-Carve. I'm talking Shapeoko. And not the current edition, but the earlier edition. Some of you have some of the smaller hobby machines. Now, it may be possible, in fact, I know it's possible because I've done it, for me to use this 1/2 inch bit and cut through 1 inch thick material in one pass. It's easy for me to run this bit with this kind of a pass depth. It's easy for me to run this at double this speed. Yes, I've run it at 320 inches per minute, cutting 1/4 inch deep. I've done it. My point, my whole reason for bringing this up is I don't want to be that guy who pressures people into overextending their machines or their tooling. I'm not here to bully anybody. I'm not here to say, oh, your machine is capable of cutting that at 200 inches per minute. My last CNC router wasn't capable of doing that. My last CNC router, the rapid rate was 200 inches per minute. And I'll let you in on a little secret, with the exception of this bit, because I didn't have 1/2 inch tooling, all of these other bits are using the same speeds and feeds that I used on my plywood Gatton CNC machine. Mainly because I know people are watching, and I know people are and I don't mean this as to have an inflated ego or anything. I know people are watching, and I know people are looking. Oh, what feed rate did he put for that? What pass depth did he put for that? So I'm going to use conservative numbers and let you work it out on your own. Okay. Now, 8th Center is asking, where'd it go? It just went right off the. Your spindle is 3 horsepower, isn't it? 4 kW or so. My spindle is 4 kilowatt. Excuse me, 4 kilowatt. 4 horsepower, which is, let's see, 4 HP. 4 horsepower in kilowatt. Yeah, 3 kilowatt. So, and I'm not, Marie had a question here also. So conservative settings for the Shark, I would start with conservative settings. And then you can adjust things from there. Okay? It's totally up to you. If you're happy with the result you're getting, then maybe the settings you're running are right for you. Okay? So I start with conservative settings and I adjust from there. Now, I don't want to spend a lot of time talking about feeds and speeds. The main thing that I wanted to get at is that's where the number of passes comes from. It's directly connected to what you have set for a pass depth here. At this rate, going through this thick material, it's going to take 4 passes. So, but what if we need something special? What if we need it, we're cutting through materially. We're cutting through material that we can go through a lot faster. Okay? This is not a piece of maple. This is a piece of foam. And we can cut through that in one pass. Well, there's a couple of ways of doing it. You can go over here into Edit, click on Edit, and I'm running 0.875. I can change that pass depth to 0.875. And boom, off I go. I can also change the feed rate, the plunge rate. Because it's a soft foam, I can just go through it. It's no big deal. And this is generally speaking the way I do it. There's another way of doing this as well. And that is using edit passes. And this is what we're going to talk about because it gets overlooked quite often. Now, just starting at the top here, note that this is pretty customizable. We can do a number of things here. I can set the number of passes down here on the bottom. So if I just want to real quick change that from 4 passes to 3, I can drop that down to 3 passes, click on Set Passes, click OK, and now it's going to do it in 3 passes. But what if I need something special? I'm going to go back up here to the top, and we're going to take a look at this diagram. Okay? Now, right now, what we're looking at is we're looking at 0.2917 inches per pass. My pass depth was 0.25. So what I've done is I've overridden that pass depth, which I can do if I'm cutting in a softer material. But if I'm cutting into a harder material, maybe I need more passes. So I can adjust that here as well. But what I can do is I can look at this and I can see, wait a minute, if I do this, this is 7 passes and it's going to get me 1/8 of an inch per pass. Okay, I can do that. but then I have to hit set passes. Otherwise it goes away. Okay? Now, this is also customizable. This diagram up here is showing each pass, and the one in red is the pass that we're talking about. It's pass 1. I can click over here on this diagram and highlight the second pass. It's pass 2. I can click over here, and there's the third pass. Now, if I want to eliminate passes, maybe I decided I don't need 1/8 of an inch, I can come along and I can double click the second pass, and that's gone. But my third pass depth stays the same. I can come down here and double click that, but my second pass stays the same. I can come through and I can edit the number of passes that way as well. So I've got 1, 2, 3, 4, 5, but they're uneven thicknesses. They're uneven depths. Set passes. That brought me back up to the 7 I wanted. Now I can just select it, click delete, select it, click delete, select it, click delete. Now I'm down to 4 passes. Now how does this apply? How is this useful? Well, let's say I'm not using that 1/2 inch bit. Let's say I've got 3/4 inch material. Okay, so we got 0.75. All right. And I'm not using that 1/2 inch end mill. I'm using a 1/4 inch end mill. Now, the pass depth on my 1/4 inch end mill is 1/8 of an inch. Okay. Already, that's a little shallow, even for me. If I'm cutting through plywood, I'm probably going to change this down to 4 passes. So I would click on this, and boom, boom, 4 passes. Set passes, okay. No big deal. Or I could do that in the edit screen and change the pass depth. However, do you remember what these measurements, do you know what these measurements are? Not really. Here, this gives me a way to look at them and see exactly what that means. So if I bring that up to 5, okay, I'm going 0.15 per pass. I think that bit can handle that. That's no big deal. What if I come down to 4? It's 0.1875, 3/16. I can come down here 1/4 inch. All right, 3/8 of an inch per pass. Can my bit handle that? It might be able to, but I'm not sure. So what if I want my first pass? What if I want to do, what if I want to add a pass? Okay, so I've got 3 passes here. But I want my first pass to be 1/8 of an inch. So I'll put my first pass at 1/8 of an inch. No, I'm not going to do that, as a matter of fact. I'm going to do 3/16 of an inch. I don't remember the decimal equivalent for 3/16 of an inch right off the top of my head. So I'm going to let the calculator do the work for me. I'll go 3 divided by 16 equals, and it gives me the decimal equivalent. Okay? So I want my first pass to be 0.1875. Now, if I select that pass, that depth's a 1/2 inch. It might be able to do that. I'm not sure. I want it to be 3/8 of an inch. So we'll go 0.375. Oops. 1 decimal mark, not 2. Click apply, and now my second pass is 3/8. Now I know this will do 3/8, but I want to get that first pass to be thin. Now 8 center is saying, would you use a first thin pass, big second pass, and a thin third pass for any reason? Yes. You just answered your own question. All I can think of is maybe using a compression bit to get tidy cuts top and bottom. Yes, that's exactly the example. And that's why I've got these out. This is a 1/2 inch down cut end mill. This, I wouldn't need to use a thin first pass. I could just, split it up into 2, 3 passes, 4 passes, depending upon what the material is. If it's really hard stuff, this is a 1/2 inch end mill. So if I'm really cheesed off at the material, I'll switch up from this to this. Guess who's going to win? The CNC router is going to win. We all know the answer to that. But this sucker will move some material, I'm here to tell you what. It'll sling stuff everywhere. Anyhow, the reason that I would use a thin first pass is with a compression bit. Now, this is a Jenny bit from Cadence Manufacturing and Design. Hashtag not sponsored. And it was designed with home hobby CNC routers in mind. What a compression bit is the top portion of this bit is down cut, but the bottom portion is up cut. And what this will do is, as you're cutting, this will give you a nice smooth bottom finish and a nice smooth top finish without all the chip out. This is great for sheet goods. So you're going to get a nice clean top surface and a nice clean bottom surface using a compression bit. The problem lies in that initial plunge. That initial plunge into the material where it first starts cutting. If you don't have that upcut portion right there at the bottom, if you don't have that buried below the surface of the material, it's the same as using an upcut bit. And you're going to get chip out on top. So for that first pass, it has to go in. Then you can worry about cutting the rest of it. Now you say, well, why then would you need for this to go in real shallow and then the rest to go in real deep? Well, it's easy, because you want to bury that first one down in the material and make a first pass before you then finish cutting the rest of it. Okay? This is how you control the depth of that first cut, so that you can bury that upcut portion of the bit down in the surface of the material before it starts messing up the top surface of your material. Let's see here. Dion says, I found that compression bits tend to scream out loudly. They can, because you're upcutting and downcutting at the same time. And compression bits, they tend to be pushed a little bit faster, and that's okay. But the compression portion of that bit, where the upcut meets the downcut, you're packing a lot of material in there. And there's a lot of screaming going on. Back off of the feed just a little bit, say 10%. Back off of your feed rate just about 10%. See if it still goes. But yes, they are noisier than upcuts or downcuts because you're cutting in 2 directions at the same time. Sam Spade's asking, you use a ramp and lead in to get to the depth of the downcut portion? That's a good way to do it. That's a good move. And yes, whether you're using a compression bit or not, I almost always ramp on a profile. Okay? Almost always. If you're trying to get that compression, um, I'm banned from running the compression bit at my makerspace. Well, you know, so. Okay, now Ray Dixon says, wouldn't you be better off just starting with a downcut bit? You can do that. Remember my mentor Michael Mazalik's mantra. There are at least 3 answers to the question. You certainly can do that. But now you've introduced a bit change. If it works for you, great. Start with a downcut bit, cut whatever portion you need to cut through, and then switch over to a downcut bit using the exact same vector, or switch over to an upcut bit and go for the gusto. You sure can. The only thing I would say is you've just added a tool change. So, but Pete at Nature's Live Edge says, will you get chip out on the ramp in? If you're using a compression bit, probably. Until that upcut portion is buried below the surface, you're going to get chip out. And that's where the leads come in. Like Dave, a.k.a. Sam Spade, says, that's where a lead comes in. A lead, you can start your ramping in, say, a ½ inch away from the actual vector, so that you know that it's ramped in and buried before it gets up there and starts cutting around that vector. So ramps and leads working together, ba-boom. Michael also says most fires are started by a downcut bit. I would tend to agree with that, Michael. I learned my lesson early on. It was like the second project I had ever done, and I was drilling a lot of holes. Dummy me, not knowing any better. I used a downcut bit to drill holes. And by the time it got into the 3rd or 4th hole, I had started a fire. That's not anecdotal. That's not, I heard from a friend of a guy who knew a guy who had a cousin. That I did it. I started a fire on my spoil board. So, and it can go just like that. If I'd have gone in the house to, for a bio break or a, make a sandwich or what have you, I could have walked outside to a burning shop. So, yeah, and had to waste a perfectly good Pepsi putting it out. Yes, I did. Yeah. So, yes, do not use a downcut bit for drilling. Okay? So, well, what bit are you supposed to use to drill holes? Upcut bit. An upcut bit. Or a drill bit made for CNC. But they will be upcut. So, all right. PM CX2 says it does go just like that. Yes, sir. But I have found, I'm not an expert. I am not a CNC expert at all. And I've been doing this for right about 10 years. In that short amount of time, I have found that by the time you can get to the panic button to stop the machine, it's already too late. So if you have the time to reach for a fire extinguisher, it's probably already too late. Hopefully not. You see my one fire extinguisher right there? That's not the only fire extinguisher I have out here. Keep them handy. That one's right there in case I'm over there gluing up at the panel clamp station. Yeah, and you need more than one. Because if you got to cross a room to get to it, it's too late. But yeah, have a bunch of them. Anyhow, let's get back here. So let's go back over here. So what I'm getting at is you have multiple ways of adjusting and editing these passes. You can adjust them so that you can start with a shallow cut, or you can start with a slightly deeper cut. Let's say we're going to bring this back up to 4, 5. Let's bring it back up to 6 passes of 1/8 of an inch. Okay, set those passes. But now I need, because I'm running a compression bit, I need it to be that 3/16 of an inch so I can get that upcut portion buried down under the surface of the material on this first pass. Okay, real easy. I can change my pass 1 to 0.1875, click apply, and now that first pass is going to be deeper. And then I can come along and get the rest of them at the correct pass depth. So I've got the same number of passes based on my pass depth in the tool database for that bit. But that first pass is going to cut slightly deeper. I click OK. Then if I calculate the tool path, and then we take a look, we zoom in here real quick, we can see that first pass is shallower than all the rest of the passes. Or no, it's deeper actually. Or is that shallower? Anyway. Yes, it's deeper because that's going to plunge deeper into the material, leaving less of a second pass than the third pass. So, all right. And that's in the profile toolpath. Let me delete this. I don't need this. Now let's go into the pocket toolpath because we have other ways to mess around with this here. Now, we're going to use the same vector. Back in the two, yes, we're going to use the same vector. And I'm going to pocket this, I'm going to pocket it 1/2 inch deep. And will you quit putting a second decimal in there, Mark? You only need 1. All right. And I'm not going to use an 1/8 inch tapered ball nose. So we're going to remove that. I'm going to select. And I'm going to use just a 1/4 inch end mill. 1/4 inch end mill with a pass depth of 1/8 of an inch. Select. Now, that's going to be 4 passes to get that 1/2 inch depth. Well, I know that I don't need, I know that this end mill's perfectly capable of cutting a 1/4 inch per pass. Will the pass depth take the toolpath pass depth? Okay, if you're talking about within the edit passes, this will override your pass depth. Okay? And that's why it is done on a case-by-case basis. Now, let's say that you are running a... the tool, the pass depth I put in here, anything I do in here will override the pass depth that is set in the tool database. Yes, that is the case. So I have a 1/2 inch cut depth. I have a 1/4 inch end mill. But now we're going to talk about tool deflection. This tool is very, very capable of cutting deeper than an 1/8 inch per pass. Okay, so let's go in and let's edit these passes. I don't need to cut a 1/2 inch, an 1/8 inch per pass. I know that at the very least, I can do it in 1/4 inch pass depths. I know that it'll cut a 1/4 inch deep. The problem is we're going to have tool deflection to worry about. When a tool is taking off a lot of material and ejecting those chips, be it upcut, downcut, whatever, you're putting a lot of sideways stress on that bit to the point to where it can deflect just a little bit. Also known as it's actually bending slightly. Now, most solid carbide bits, while carbide is brittle and it's easy to shear off, if you've ever broken a bit, you know this, it will still bend. Carbide is brittle, but it will still bend, and that's what tool deflection is. You're pushing that bit through, in this case, a 1/4 inch of material per pass to remove that material quickly and get it, that 1/2 inch pocket cut in 2 passes. The problem comes when you're down at the bottom pass. When you look at the bottom surface of your material and you think, well, that could look cleaner, but there are some tool marks. Here, we can set a last pass thickness. So let's say I've got it set for 1/4 inch per pass. That's fine. But I can check this here and set a last pass thickness of, let's say, 30 thousandths of an inch, 0.03. And we click apply, and I've just added a 3rd pass. But that 3rd pass, it's only removing 30 thousandths of an inch of material. So what this is doing is it's giving you kind of the same option you have when you do a 3D roughing toolpath and you use a machining allowance of 0.03, so that when you come back and do your finishing toolpath, that's how much material is being removed. This is about the same as that option, so that you can hog out a bunch of material and then come take a final skim and get a nice smooth bottom in that pocket. You click OK, and we're now at 3 passes. So when I look at this pocket and I calculate it, kind of stand it up here, we can see we have 3 passes. First pass is going to come down to this level and hog out all this. Second pass is going to come down to this level and hog out the remainder. Then the 3rd pass is just going to clean up the bottom of that pocket, reducing the amount of possible deflection and give it a cleaner bottom. Okay. Leo Steger is asking, what is your rule of thumb for pass depth per diameter when cutting wood? In a metal shop, it is 1/2 the diameter of the end mill. I recommend to folks, when they're just starting out, to use this same rule of thumb, 1/2 the diameter of the end mill. When you're first starting out, you're trying to learn everything at once. You have to be able to learn how to design, how to mount the material, how to use the machine, what it's capable of, what you're comfortable with, what the material is going to allow. So I recommend, when you're just starting out, half the diameter of the end mill as the pass depth. But, and you can see the pass depth of my 1/4 inch end mill is 1/8 of an inch. So I follow that advice. That's a conservative number to start with. So what I'll do from there, when I get comfortable with the machine, when I know what the machine is capable of doing, I can bump that up. My rule of thumb after the fact, after getting to know what the tool can do with whatever material, I run pass depth equal to the diameter of the bit. But only if I'm comfortable that my machine can do that and the material will allow that. You know, there are a lot of folks who can't, me included, who can run certain materials really fast. But if I'm cutting highly figured maple, or it's particularly hard maple or purple heart, the material won't let me cut that at 300 inches per minute. It just won't. Where I could do that with, you know, pine or something, it just won't. So it depends big time on the material. But I'm comfortable enough in knowing my speeds and feeds that yes, I can have some materials I can cut at an equal pass depth, a pass depth equal to the diameter, but not necessarily. What about depths of cut on surfacing bits with removable carbide blocks? Well, I happen to have one such bit. So let's get back into the tool database. Ba-boom. And that is my 2-inch Amana RC 2255. The pass depth was dictated by the manufacturer. They said in their tool database for this bit to use a 1/8 pass depth. And it's 2-inch diameter. But it has the removable carbide blades. So that was dictated by the manufacturer. Now, having said that, I messed up once. Big time. And I did not reset my Z0 when I switched over to the the surfacing bit. And I wanted to surface a piece of leopard wood. In fact, I was surfacing the piece that I used for the final pirate epoxy pour that I gave away. Okay? That was a mistake. I know, but I was waiting for this, having said that moment. Well, it was a mess up, and it was not intentional. Trust me. I hit cycle start, and I watched. I turned to my back and was coming over to the table saw for something, to grab something off the table saw, and turned back around. Before I could turn back around, I heard a god-awful. I thought, oh, that's not good. And I spun around and looked, and I watched that surfacing bit go through do a 3/8 inch pass. 3 times the recommended pass depth. All right? At 240 inches a minute. And that spindle didn't feel, well, it felt it at first time. The spindle didn't feel it. The bit didn't feel it, and that the surface came out nice and smooth. I thought, well, nothing's blowing up, nothing's on fire, let it finish. It was just a small piece. It took 3/8 inch thick passes. Let's put that into metric. 0.375 inches into metric. That's 9.5 millimeters in one pass. 9.5 millimeters. But it worked, and that surface was just as smooth as glass. That's why I love this bit. So, what can you say? Let's see here. Marie at Acrylowood Design says, this week I had a conversation with John Hennon. He makes his fees and speeds the same on the Maverick. I was a little concerned about this, though if I trust anyone, it would be him. If it works, then that's fine. You know the machine a little bit better. You're not just starting out brand new to it. And if it works for you, it works for you. Remember, 3 answers. 3 answers. So, let's see here. Jay Scotia says, surfacing bits generally don't cut in the center. Exactly. So you have to make sure you ramp in. Plunging to depth of cut will cause problems. Yes. The other thing I do is I make sure that all my plunges, when I'm surfacing, all my plunges and all my movements in, okay, I surface along my Y, parallel with running with the gantry of the machine. I make sure of all of my X movements are done off of the machine, as well as my initial plunge. So with that 2-inch bit, I'm the guy that makes the rectangle slightly bigger than the piece of material. With this bit, I make it 5 inches longer and a 1/2 inch wider. So I know that bit's going to go off the side of the material by 1/4 of an inch. But I know the plunge is going to be done off the material. It's going to then come across the material and do its surface, off the material, then move over, then come back and do like so, then move over. Been doing that since day one, and I've yet to burn a piece. I've yet to have machining marks where you can see that scoot over. Been doing it since day one, and I've had nothing but nice smooth finishes, especially with that Amana RC2255 bit. I know there are other less expensive bits out there. This one was recommended to me by Shane Peters and Rob Sandstrom for doing epoxy. I know Rob has since moved on to another different type of bit. I'm not sure exactly which one. But this Amana bit, they said it was the best. Shane said he tried them all and this was the best. So that's what I got. And it works. So, okay, Marie says it came out beautiful, but I'm still learning. So am I, Marie. The learning never ends. The learning never ends. Every day's an education. And that's how it should be, to be honest with you. The minute you think you know everything, you become dangerous. And I say that because that tells me that you're not interested in learning something new. So, in the Pocket Toolpath, we have the ability to edit the number of passes in case we want to make this last pass a little, just a skim, to let that bit remove just the last little bit of material. But we have all these other options available to us as well. We can increase the number of passes if we think that's too aggressive. We can decrease the number of passes if we think that's not aggressive enough. We can do a combination of the two and say, I want to come down here and do this, and then set a last pass thickness of 0.02 this time for some reason. And we'll apply that, and we'll have a very, very thin skim at the bottom. So, did you point out that you can double click the bar to add passes? Not yet. I did point out that you could double click the bar to remove passes, but you can also double click right there and add another pass. Double click right there and add another pass. Then you can modify that depth. Let's say you want that one at 125 for some reason. Click apply, there you go. You can also clear them all and start over. But I still have my last pass set at 0.02 because this is checked. Okay? Clear all passes. Now they're all gone. It's going to cut it in one pass. Okay? I don't want to do that. I want some passes here. Let's go with that. Set passes. Okay. My point in all of this is you don't have to accept what this says or what this limits you to. You can change a single pass. Or 2 or 3 passes. So, let's see here. Mark, which bits give a finished edge so you don't have to sand as much? I don't think any such thing exists in the CNC world. The only thing I can think of is laser. But I could be wrong. If you out there have a particular bit that's going to give a nice, clean, smooth edge and reduce the amount of sanding, throw it in the chat, or if you're watching this on replay, put a comment. Just know that you cannot post a link. YouTube won't let you post a link. Marie, again, I've only been doing this for 10 years, but I have yet to have a single project come off the machine finish ready. All of them require a little bit of sanding or a little bit of cleanup. Now you said, so I don't have to sand as much. I'm just going to say make sure it's a clean, sharp bit. Oops, didn't mean to do that. Just make sure it's a clean, sharp bit. Clean your bits when you finish using them. And if you start getting less than clean, pretty cuts, it's time to replace it. Bits are consumables, okay? They're not going to last forever. And I know if you've spent a lot of money on bits, it kind of breaks your heart to throw a bit away. If you have a sheet metal scrapyard somewhere near you, throw them in a coffee can, and when you get a coffee can full, take them in, and they'll buy the carbide from you. They'll buy the bits from you. Michael Mazalek says using a last pass is a good way to help with that. Yes, it is, as we discussed last week. Using a separate last pass on a profile cut will help you. And in fact, I use a separate last pass on all profile cuts where I'm cutting out a part. And I set my allowance at 0.01, so 0.010 of an inch. Yes, a smaller step over helps. But again, I've yet to have anything come off of the... that's what I use, Marie. A separate last pass with 0.01. The higher number you go, the more that bit has to take off. So 0.01 is a good, reasonable amount. There really isn't any adjusting. I don't know that I would really adjust. So, um, 8 Center says, I watched something this week suggesting you don't need to sand much above 180 grit on most woods anyway, because most people can't tell the difference. All right. I've been doing CNC for 10 years. Let me bring this down. I've been doing CNC for 10 years. I've been a woodworker in one way, shape, manner, or form. Okay, now 80, not 180. Okay, I got it. Yes, 80 grit. Okay. I would disagree with that. Bring back the original comment. Make sure I didn't get it wrong. Yes, I don't need to sand much above 80 grit on most woods anyway, because most people can't tell the difference. I disagree with that. Again, I've only been doing CNC for 10 years, but I've been a woodworker in one way or another for over 50. Okay? And I can tell you right here and now, yes, people will notice the difference above 80 grit. And if you want to prove it to yourself, try it. Just do it. Take it up to 80 grit and see what you think. Feel it, touch it, take a look at it. Shoot some finish over it. And tell me you want your name on that. More often than not, you don't need to go above 220. Try cutting a gun stock and sanding it with 80 grit. Yeah. Yes. More often than not, you don't need to go above 220. There are exceptions to that. Most people oversand. I will say that. If you're going above 220, there needs to be a reason. Yeah, Jack in the shop. Yeah, I sand up to 220 yeah. Barry Lane says my wife can tell the difference between 150 and 220. Generally speaking, those are the only two grits of sandpaper I really use, is 180 and 220. There are exceptions. Or excuse me, 150 and 220. There are exceptions. Guitar fretboards. When I make a guitar neck, I sand the neck up to 220, the back of the neck. I sand the fretboard to 4,000, but the fretboard doesn't get finished. And that fretboard has to be as smooth as glass. It has to be so that the guitarist's fingers can slide and they don't pick up a splinter, heaven forbid. The problem comes in when you can't burnish the wood and expect it to hold a finish. And when you get to 320 grit, you are starting to burnish the wood. It depends on what kind of a finish you're going to apply. If it's a surface finish, lacquer, shellac, polyurethane, something that's going to sit on the surface and cure. If you burnish the wood, you really risk it chipping off. It becomes harder for the finish to hold on to the wood because you have closed those wood pores. You've burnished them. It's easy to burnish wood with 320, but if you use light pressure and a sanding block, you can successfully sand at 320 without burnishing it. End grain cutting boards, I sand up to 320 because I'm not using a surface finish. I'm using an oil. If you're using a hard wax oil, you can sand beyond 220 and 320 and not concern yourself because the oil is going to penetrate. Okay, Pete, Nature's Live Edge. And this man is an artist, I'm here to tell you. This man knows his stuff. Quilted maple, 800 and up for sure. He has made some stellar pieces. Truly gorgeous stuff. But he uses an oil finish. So if it's got a penetrating finish, you can sand beyond the 320. So, okay, let's see here. We had another question. So I don't agree with the 80 grit and stop. I really don't. But then again, it depends on what it is. If you're talking redwood patio furniture, 80 grit may be all you need. If it's something that's going to be hung up on a wall and seen from, 20 feet away, 80 grit may be all you need. But if it's going to be something that you can put your hands on, no. Okay, Stubbs' mom says, sometimes cutting a profile pass, the piece I'm cutting out comes loose before it's finished and bounces into the bit or out, even breaking tabs. Do I need more passes or more or thicker tabs? Yes. And I'm sorry, but that it's one of the three or a combination of the three. Okay. And let's get over here and talk about it. Let's go back in here. I'm going to close this. I don't need the toolpath. I need profile toolpath. Okay. I've got my piece selected. Let's say it's 6 passes. I'm going to go for, let's bring it down here. Yeah, let's do that. 0.15 per pass. Set passes. Okay. And now we're going to come down here and we're going to add tabs to Toolpath. All right. Now, what we have here is not a failure to communicate, but what we have here is a bunch of choices and a bunch of variables. Okay. If it's breaking loose, you're either your tabs are not long enough, they're not thick enough, or a combination of the two. One or the other. Or you may not have enough tabs. So, close. We go into Edit Tabs. And I'll be honest with you, I don't use any of this. I really don't. I don't use any of this at all. This is just me. To add a tab, I go out here and I click. Anywhere you see that check mark on the cursor, you can put a tab. I go for flat, straight areas like so. I avoid inside corners like the plague. Do not put a tab on an inside corner. You are going to have a fit trying to sand it out. I try to avoid outside corners too, if it's possible. Sometimes you can't avoid it. You got a big circle. How do you avoid a curve? You can't. Now, depending upon how big the piece is you're cutting out, 2 tabs may be enough. But if you look, I've got them right out here in the middle. There's a lot of vibration that can happen out here. So let me go ahead and put a tab here and a tab here. If you're having problems with 2 tabs, go up to 4. If you're having problems with 4 tabs, you might need to go to 6. Meaning, instead of having this here, and you can move a tab just by putting your cursor over it and dragging it. And then add another one there. And do the same here. Move this over here, and then add another one there. Okay? It's not important that they be lined up perfectly. It's important that they support the piece. Okay? So I have the locations set. So I can close this. And now I've got to decide on the length of my tabs. The length of the tabs are 1/4 inch. Well, how big is this piece? This piece is, and we're looking at about 5 inches wide. 6 1/4 inch wide tabs might be okay. But be on the safe side, I'm going to go with 1/2 inch wide tabs. And the thickness needs to be a lot more than 1/8 of an inch, depending on the thickness of the material. The thickness of the material is going to help you decide on how thick your tabs should be. 1/8 inch thick tabs I use on 1/4 inch thick material. And that's about all. Maybe 3/8 inch thick material. Depends on what I'm doing. Okay? But generally speaking, I'm going to go with 1/4 inch or above on just about anything. Now, if I'm going with a 1/2 inch long tab, 1/4 inch is about right. But there's another factor here to work with, and that is 3D tabs. 3D tabs are a trade-off. If we look at the little diagram here, I'm going to take that off. A normal tab, the machine will cut around until it gets to a tab. It will stop. The Z will lift to the tab thickness. Move over to the other side of the tab, plunge back down, then go till it gets to the next tab. Stop, raise up to the tab thickness, move over, plunge again, and go. That's 6 stops and 12 Z movements it's going to have to make to cut around here. Okay? If you go with 3D tabs, you can see right here that what it's going to do is it's going to come up to the tab, and then the Z will start lifting at the plunge rate until it gets up halfway, so 1/4 inch in, up to this thickness, then it's going to start plunging again. So your X and Y never stop moving, but it will slow down to whatever the plunge rate for that bit is. Because again, the machine only moves at the speed of the slowest axis, which is almost always the Z. So you gain a little bit of speed when you're doing 3D tabs in that the X and Y never stop moving. But what you've just done is, and I wish I could blow this up a little bit. What you've done is you've taken the whole combined thickness of 1/4 inch, and the only thickness of that tab that is 1/4 inch is right in the center. That's the peak. So it's a trade-off. If you're going to use 3D tabs, they should be thicker. If you're going to use standard tabs, they can be a little bit thinner. Okay? But if they are breaking loose, so not as strong with 3D, in a roundabout way, yes. If you're doing 3D tabs, they should be thicker than if you weren't using 3D tabs. Now, having said that, that check mark was there for a reason. I use 3D tabs, but I also make them a little bit thicker. So I might make this 0.3 instead of 0.25. So it's a little bit thicker. Okay? But if it's breaking loose, the first thing I would do is make the tabs thicker and longer. If you can't make them thicker or longer, use more of them. Leo says, Mark used the mouse wheel to blow up your material. Yeah, I know that, Leo. I can do that. I was talking about this diagram over here. Okay. I was talking about this diagram. I wish I could zoom in on it, but as it sits right now, I can't. So, yeah, tabs are, I use tabs all the time, especially if I'm using the composite nailer or screws to hold down the material. I use 3D tabs. So if it's breaking loose, one of three things needs to be done. Either the tabs need to be longer. Well, I would go with, in order of importance, tabs need to be thicker. You need more tabs, or they need to be longer. So, my general rule of thumb, if I can, if the project allows it, is I put tabs on straight edges, if it's possible. And the 8 center's absolutely right. If something has a lot of curves, you want more tabs too, because there are more forces pulling in all 360-degree directions. Absolutely right. Absolutely right. But even on my simple rectangle here, I've got long passes going in the X directions and then short passes going in the Y direction. So, you know, Pete says end grain tabs tend to be stronger. Yeah, if it maintains that, remember that what wood is made up of, if it makes up the integrity of those cellulose fibers that are holding that thing together, if they're down like so, you've got one layer. I mean, this is not going to be as strong as this. And none of it's going to be as strong as that. So, but if you, probably the easiest is to just add more. If you can at all possibly do it. So, 3D seemed to leave less of a witness line. Yeah, I use, I have a little palm router with a flush trim bit that I use to clean up tabs. So it just routes it right off. So, I also have a 1/2 inch bit. We'll have lots more. Also, a 1/2 inch bit will have lots more pull than a 1/4 inch bit. Don't ask me how I know. Oh yeah. Oh yeah. An upcut bit, you're fighting all kinds of forces when we do this. We think that we're doing okay. An upcut bit is going to try to pull your material up. A downcut bit's going to try to force your material down into the table. Okay. A flush trim bit, let me go, see, where did I put it? Okay, let me go get one. Had to go get my hand router stuff, which is in that toolbox back there. Flush trim bit is not made for CNC. It's made for a hand router. Okay? It's made for a hand router. Flush trim bit is a straight bit with a guide bearing on one end. You can get them with the guide bearing on top or on the bottom like this, or on the top like that. And I have both styles. I use the one with the top bearing, and that rides on the edge that has already been cut by the CNC. If I'm using the one with the bottom bearing, I flip it over so that this bearing rides on the edge that was cut with the CNC that doesn't have a tab. So I'm trimming the tab off with this. So now I do this on a trim router because it's just trimming off a tab. It's not hogging off a lot of material. And that's the quickest way that I have found to clean up after tabs. So I'm having trouble keeping my edges square when using a palm sander. You might want to look into an edge sander. A lot of people, you might want to look into an edge sander and or a oscillating spindle sander. Now, a lot of people like the rigid oscillating spindle sander because it's both. It's an edge sander and an oscillating spindle sander. That'll help you keep the material nice and flat. It's real good. The edge sander can help you with outside curves, and the spindle sander is great for inside curves. But you still have the problem with the radius of the spindle. I picked up a cheap Harbor Freight oscillating spindle sander, oh God, years ago. And it's one of the better tools that I've picked up from Harbor Freight. And I got it cheap off of Craigslist. I got paid $40 for it. And it has several different sizes of spindle, up to, I think, 2-inch diameter. And it works very well for inside curves. And it stays nice and square to the table. So, but the rigid that's sold at Home Depot, you can put a belt on it. So it'll either work as a spindle sander, but it'll also work as an edge sander. And the reason they call them oscillating is they not only spin, but the sandpaper spindle also moves up and down. And the belt also moves up and down. So Butch Miller says his jet spindle sander goes from 1/8 to 4-inch diameter spindles. Yeah, that's kicking some serious butt. I think the Harbor Freight goes down to 1/2 inch. But I may be wrong there. I got to look. I don't know. So, no. Yes, I think it goes down to 1/2 inch. It might go to 1/4 inch. I don't remember. Anyway. But yeah, if you're having problems with like a random orbit sander or a quarter sheet sander, it's... let the machine do the work. Or in some cases, I mean, that's why I have a lot of this kind of stuff, little chunks of dowel floating around. Sometimes you have to get in there and sand it by hand. But to make things easier on you, throw something else out there. If you're going to be doing a lot of hand sanding, especially detailed stuff, little trick I was shown back in the cabinet shop or the furniture shop. I don't remember which. Anyway, loosely wrap your fingers in first aid tape. You know, like the silk tape that you can get in the where they have the gauze and the ace bandages and all that other good stuff in the first aid section. Wrap your fingers in that tape. It's one insulating layer between you and that sandpaper, and you have a lot fewer blisters. And keep your fingertips nice. Jack in the Shop says, I have the Harbor Freight one too. Mine was a little more than $40. Yeah, I don't know what they are at Harbor Freight. Like I said, I got mine off of Craigslist. It was used. And I gave the guy $40 for it. He was more than happy. I've been more than happy with it ever since. But yeah, it works, Brooks. I'm watching one of the guys do that. And I'm like, what are you doing? He's like, well, it keeps me from, protects my fingertips. And sure enough, it worked. So, But he did it for 8 hours a day, whereas I didn't. I was just helping out. Okay. Did I get to everybody's questions here? I see here. Yeah, it looks like I did. Does anybody have any questions? Any comments? Any concerns? We've been on for about an hour and a half. I've sanded so many fingernails off. Never hurts till the next day. Yeah, I've sanded my fingerprints off. You know? I have. I've sanded my fingerprints off. It does not feel good, believe me. I've bumped. You didn't get to my warning, but I think you got all the cues. Let me go back up, see if I can find your warning there, man. Don't mean to ignore anybody. Little glue and tape method can help if tabs aren't working. I use glue and tape. I've gone on the record. I use that a lot, really a lot. And, but it depends on what I'm cutting. And depends on, you know, what the toolpath is. Let's see here. Can I comment on the reversed pass, please? Oh, on a separate last pass, reversing the pass. That's all that means. Say if you are cutting conventional, if you want to reverse the pass so that on your separate last pass, you're cutting climb, you would check that. I have never used it, not once. I don't bother with it. I cut conventional all the time, and I don't reverse the pass. That's up to you. And you know what, Marie? Try it. If you get a better result, give it a shot. I mean, if you get I would try it on scrap first. If you get a better result, then that may be the way to go. Just know that not every material will respond well to reversing the direction. I've never used it. I don't know that there is a benefit. So, let's see here. Can you mail a watermelon using food stamps? No, but thank you for playing our game. I do like those kinds of questions, those. I think my favorite one, and you would get this, Butch. Why did kamikaze pilots wear helmets? Let's see here. I don't see your warning 8 center. If you could put it back in there, if you could put it in there again. It must have been way, way back because I've gone quite a bit up there. Okay, this is about epoxy. I'm getting too many bubbles and I don't see them until I do the surfacing on the CNC. Okay, what I have always done, okay, there's a few things that work here, all right? They could be that you are not popping the bubbles with the torch, heat gun, whichever you use, enough or long enough. Or you might not be sealing the wood before you pour your epoxy. What I mean by that is, on all of my epoxy projects, inlays and what have you, I will seal the wood by mixing up a little bit of clear epoxy and brush that in. Brush it in to seal the wood before you pour the color. Like we're talking the day before you pour the color. Because anytime, every time that bit touches material, you are creating end grain. And the end grain, two things are going to happen. The end grain is going to get sucked into that end grain, and it's also going to release air. So if you just pour into bare wood, you're going to get a lot of air bubbles because air is going to force its way out and it's going to go up and you're going to end up with air bubbles. The other thing is it's quite possible, Ray Dixon picks up another good point here. Moisture in the wood. What is the moisture content of the wood that you're using? Without a moisture meter, that's hard to define. It really is. And no, you may get 2 or 3 readings on the same board. But if we're talking about something like MDF, where moisture really isn't a concern, it could be that you didn't seal the project first, seal the material first, and or, because there are variables here, it's quite possible that you didn't pop the bubbles long enough. My rule of thumb is I go out and I pop the bubbles with a blowtorch, just a propane torch, every 10 minutes for the first hour. Every 10 minutes for the first hour. First to second hour, I back that down to every 15 minutes. Maybe every 20 minutes. But just because you pop the bubbles once doesn't mean you got them all and they can come up to the surface again. Keep in mind, I'm talking about countertop epoxy, which is generally speaking 1/8 of an inch thick or less. Okay? If I am using deep pour epoxy, like a casting, if it's at all possible, it goes into my pressure pot. And then bubbles are no longer a factor. If I can't get it into the pressure pot, I have to seal the wood. You have to seal the wood to prevent any bubbles from that are trapped in there are sealed. Any air that's still in the material is sealed in there. So you've got to pop those bubbles and you got to seal that wood. Now, I know people who don't use, I use epoxy to seal. I know people that use 3 or 4 heavy coats of polyurethane and they have good results. I've never trusted it. The dirty secret that none of the epoxy manufacturers are telling you is that almost all of the countertop and deep pour epoxies that we're using in this kind of application are urethane based. So they will be okay about they won't interact. They won't have a bad interaction. You can finish an epoxy project with polyurethane and you can seal wood with polyurethane and then pour your epoxies in that. So all right. The CNC art download issue was the gentleman's internet service provider. It was satellite internet, and there were just a bunch of people on at the same time, and throttled down his speed, and he went to try it again the next morning, and it just went right through. It was his internet service provider. So, let's see the other one. The warning was about glitches when you edit depth of cut in the tool database. Then edit fields. It can change depth of cuts to a midway point between them, so you need to check them in edit passes. That I think that was a glitch. You need to we're on 12.506. So you need to update to the most recent version. So let's see. All right. Was that question for me? because tomorrow is the members only live stream. So my day is filled. I won't be available tomorrow. I don't even know if that was for me or if that was for Brooks. Speaking of members only live stream, see how I did that? Speaking of the members only live stream, that's tomorrow for channel members. We're 5 p.m. Pacific, 8 p.m. Eastern. You can head over to my post tabs and you can click over to that post tab and you'll find a link to tomorrow's live stream. It's going to be different tomorrow. Let's put it that way, because somebody is feeling under the weather. They're not going to be presenting something. We're going to fake it till we make it. So tomorrow is going to be a little bit different. But here's hoping it's going to be good regardless. If you don't know what I'm talking about, or if you want information on how to become a channel member, you see all these people over here who have their channel names in green, and they've got that beautiful star right next to their name. They are channel members. And they're some of the finest people I've ever had the pleasure of associating with. I'm serious. Every one of them is an artist in their own way. And they are truly some of the finest people I've ever been blessed to meet. I'm serious about this. We'd love to have you join us. So if you look down below this video panel right here, you'll see the word join. Go ahead and click on that. Now relax, you're not joining anything, you're just getting information. A panel is going to pop up and the video is going to play, tell you all about channel membership. As I said, we'd love to have you join us. Absolutely zero obligation. Did you get my answer to your question? I don't know, John. I've been live streaming. Where you been, homeboy? I'll probably get it when I go back in the house. Anyhow, yeah. So next week, what are we going to do? We just did, allowance offsets. We did pocket allowances. We've done editing passes. I don't know if I mentioned it or not, but the ability to edit passes. I knew him. The ability to edit passes is only available in the Profile Toolpath and the Pocket Toolpath. All the other toolpaths, with one exception, go by the pass depth that you set in the tool database. So if you need to kind of, maybe your V-carve is trying to burrow its way too deep, maybe you need to set your pass depth a little bit narrower. Okay. Dave, Sam Spade wants to know, why do we park on driveways and park on driveways? I still want to know, if Teflon is such a great non-stick surface, what keeps it on the skillet? Would have to be nails. I don't know. Anyhow, so let's see. I don't know what we're going to do next week, so let's fake it till we make it. You tell me. You come at me with your questions, and unless I find a really, really interesting topic to discuss between now and then, we'll do all of it. What the heck? So thank you for spending part of your Sunday with me. I greatly appreciate it. Appreciate each and every one of you. Again, if this is your first visit, subscribe to the channel. Then you can BS with us next week. Other than that, y'all have a great Christmas. Here's hoping you get to spend it with friends and family. And hang out with the kids. And give somebody a call. You have a friend, you have a family member that hasn't heard from you in a while. Give them a call. Have a chat. Not a text. Anybody can text. Yeah, give them a call. They'd love to hear from you. But for now, y'all take care. Have a great, great rest of your weekend.